Hello, welcome to the lecture series on vehicle dynamics. In the previous session, we discussed about longitudinal load transfer and acceleration in x direction. Now we'll discuss about lateral acceleration and lateral load transfer. You just observe this vehicle. It is just taking a turn like this. Well, taking a turn, you can observe here, this is the inner side, this is the outer side. The inner side suspension has lifted up, outer side suspension has compressed. This has happened because while taking the turn, load is getting transferred from inner side to outer side. Okay, so this is a circle. A vehicle is taking a turn. This we call as inner side and this we call it as outer side. So whenever a vehicle takes a turn like this, a centrifugal force comes into picture. Centrifugal force is given by mr, say m r omega square. Or I can write this as m r square omega square by r. Or I can write this as m v squared by r. V is equal to r omega. This is the centrifugal force. Force is mass into acceleration, so v squared by r can be called as lateral acceleration. I represent by a suffix y. Right. So this is the centrifugal force acting outwards. To keep the vehicle on track, these are lateral forces at the wheel road contact. You can call them as say grip forces. Correct? So sum of these four forces is equal to the centrifugal force. Then the vehicle will be following the track. Also observe here, when it is taking a turn, the load gets transferred from inner to outer side. That's why the grip force, which is also equal to say mu L say W. Correct? That is the load on these things. If more load is acting on this, the force will also be large in that case. Right. So here on the outer side, the wheels are more loaded. That's why the grip force magnitude is larger. Inner side, grip force magnitude is smaller. So maximum lateral acceleration possible, which we have discussed in mu circle, it is mu Lg. Suppose our Ay, which is v squared by r, if this value is greater than mu Lg, that means this force is larger than the force, these four forces, then the vehicle will simply slide. Vehicle will slide. Right. If it is further high, what we'll see that later. That is a different discussion, right? Right now, if it exceeds, it slides. Okay, now you have to understand that's a lateral acceleration, there's a lateral load transfer. So how much load gets transferred? So for that, I have taken the front view of the vehicle. Okay. Here you have the center of gravity. It is at a height h. W is the load that is acting. T is the track width. WR is the load on the right wheel. WL is the load on the left wheel. Assuming the driver is sitting here. So to the driver's right, this is driver's left. That's the reason why I have written like that. Okay, right, sir. Now assume that this vehicle is taking a turn. Then there is a centrifugal force acting here. Is that okay? Centrifugal force acting. Now let us find out what is the load on the outer wheel and inner wheel. So earlier in the longitudinal acceleration, load, say static load on the front, I have derived it as load on the front, static load plus W by G AX H by L. This I called it as something like dynamic load. Dynamic load. Okay. Now the question is here. It is load is transferring from left to right. Instead of wheelbase length, we have wheel track length T. Instead of linear acceleration, let us talk about lateral acceleration. Hence, lateral load transfer will be W by G instead of AX, AY, H by T. This is the load transfer. I can derive considering all the forces. Okay, so what is the load on the right wheel, load on the left wheel? Load on the right wheel, again we have done static load. When we did, it was W C by L, correct? No, that is equal to W Fs and WB by L. So that is why same W, instead of C, I am talking about this length, that is LL divided by T. This is the static load, okay, on the right wheel. Whenever it's taking a turn, this is the dynamic load that gets added up to the outer wheel. Okay, this is the static load on the left wheel, and this is the dynamic load that gets subtracted from the left wheel. Okay, so what is LR? LL, you can note down from here. Track. Okay, now we know what is the lateral load transfer. What is the longitudinal load transfer? Now let us find the rollover potential. I said one thing, if this force, centrifugal force, exceeds some of these four forces, vehicle slides. Another thing what happens, because of the load transfer, because of the suspension, this goes down and this rises up. So the center of gravity which was here, it changes its position, center of gravity position, because this load gets concentrated over here. there is centrifugal force acting. There is a weight which is responsible for rolling. Okay, so let us take moment about this point. Earlier this width was say t by 2. Correct? No, this is t by 2. Now because of the change in center of gravity position, this length will become now t by 2 minus this y. Correct? Y can be determined from here. H is height of center of gravity. This point we call it as a roll center. So later I'll explain about rolling, roll centers, everything. Okay, this is roll center. HRA is called roll center height. Fine. Now from this it is possible, this height is H minus HRA. This is what you call it as roll angle. Roll angle. So from here it is possible to find y. Correct? Sin phi is opposite side by hypotenuse. From that we can find out. Let me take a moment about this. This weight W, if I take moment, this distance is t by 2 minus y, this will create a clockwise moment. Okay. The centrifugal force, again about this point, F into H, will create a counterclockwise moment. Also there is load that is acting here. This and this distance will create again another counterclockwise moment. So that's why these two are counterclockwise moment. This clockwise moment, for equilibrium they must be equal to 0. Okay. Now what happens is, we know the load transfer is W AY by G H by T. Static load is W LR by T minus this. Say that is the load on this wheel, let us say. If I go on increasing the value of acceleration, lateral acceleration, this value keeps increasing. Right? So reach to that acceleration value, well, this load will become 0. Then there is no load, means it will lift off. All that load gets transferred to this point. Then the vehicle will roll over. Correct? This acceleration is again v squared by r. If I keep on decreasing the turning radius, keep on increasing the vehicle velocity, this can happen. So suppose, let us say you are driving on a straight road with a very high velocity. Assume that all of a sudden some disturbance enters. Then to avoid the disturbance, you take a turn like this and go. This turning radius is very small. Also you are taking a turn at high velocity. Then this can happen. Right? Now in that, if WL is equal to 0, my equation will be like this. And as I said, From the triangle, you find y is equal to this. So now W, I have taken out T out, then it will become half, in place of y I substituted, is equal to FH. F is nothing but this one, correct? No, centrifugal force. H is there, and the T which was here, I brought it down here. Okay, then I can cancel now W, and I can get this equation. Okay, let me now, keeping A y by G on left, T by H, if I transfer to this side, I'll be getting this way, this equation. Correct? So I can write like this. If Ay by G value reaches to this value, then the load on the left wheel or inner wheel will become 0 and the vehicle may roll over. But 5 values are small. If I can just ignore this value, something, then you can say Ay by G is equal to T by 2H. You can call it as static stability factor, SSF. So if I know the vehicle track width, vehicle center of gravity, I can find out what is the static stability or what is the maximum lateral acceleration. So you want to reduce the probability of rollover. It is necessary to have higher track width, also smaller height, center of gravity height. So if you take formula car and all those things, H will be very, very, very small, and chances of vehicle rolling over is not there at all, right? In fact, vehicle simply skids, slides and spins and kind of things like that instead of rolling over. Correct? That's what really happens. So static stability factor is an important factor which will indicate the rollover possibility, rollover potential. Just like this. You see here, one of the vehicle rolling over. Right? Right. Now if you see these vehicles, car, as you say, T by 2H. Here the center of gravity height is low. Static stability factor is this. In this vehicle, center of gravity height is more, so static stability factor is less. So somewhere in these kind of vehicles, as you load more and more, the center of gravity will move up. The static stability factor will be very less. Okay, these are more prone to rollover. You must have observed on highways. Sometimes if a truck is moving ahead of you, right, and you would like to, right, and your vehicle is here, correct, and you want to bypass this like this, right? So that time you keep on honking, and these people will take too much of time to actually deviate from their original planned road. The reason is that if we try to take probably a turn, since this is very small, this vehicle will be prone to rollover. That is what in many highways you must have seen. A small mistake of drivers will see that and the vehicle will roll over. Right. So these are all the problems with this kind of trucks whose center of gravity height is very, very high. So we can simulate and find what is the load on each one of the wheel. It is possible. Now the question is how exactly the lateral load transfer happens. You see here, load transfer from inner side to outer side, say inner to outer side. It happens due to mechanism of centrifugal force, this one. Through the center of gravity, centrifugal force it happens. And you see here you have suspension. So it rolls. So because of that rolling also, load gets transferred from inner side to outer side. This is as far as sprung mass is concerned. In an unsprung mass, it is not sitting on a suspension and it happens due to centrifugal force. Correct? That's why I have written total lateral load transfer is due to lateral load transfer due to centrifugal force. Correct here. Centrifugal force, suspension rolling, and unsprung mass transfer. So total all this put together, the total load transfer will be WAY by G HT. Okay, that is the lateral load transfer. The mechanism of these, I have further explained this, but I will be repeating this, right? This is a centrifugal force, that is non-rolling load transfer, that we say through the roll center we transfer like that. Second one is rolling due to suspension, right? And third one is due to unsprung mass. That's how we talk about and sum them up, and that will be the total load transfer we say. Now let us write the equation here to the front. When I write W C by L, correct, plus or minus W by G AX H by L, correct. Let me write divided by 2 WC by L minus or plus, minus when it is accelerating, plus when it is deaccelerating. Say 1 minute. Minus plus W by G AX H by L, correct now, by 2, because it is total axle, so that is the reason why I am going to write by 2. Here it is WC by L plus or minus W by G AX H by L by 2 and W by C by L plus or minus W by G AX H by L. Again, left, right. What is that load? W. I'm talking about left, so LR by T, correct? No, plus minus W by G A Y H by T. For this wheel you can say half like this. Okay, here W L by T minus or plus AY, sorry, W by G AY H by T by 2. Okay, suppose the vehicle is accelerating. The load here is WC by L minus W by G AX H by L by 2. That is the same thing here. Here it is plus this thing. It is accelerating and let us say it is taking a turn like this. This plus load gets transferred from inner to outer. So it will be plus. Same here on this side it will be minus. Thus at each point what is the load on each one of the wheel we can find out now depending on the condition. In addition to that, you can look at the gradient. The gradient loads also added. So each instant what is the load on the wheel you have to find out. This theory, this understanding will help in designing vehicles acceleration performance as well as braking performance. Okay, that's a very important. Right, this is what the discussion so far, like how to find the load on each axle. Finally, what is the load acting on each one of the wheel at a given instant, right? So you can see here some example. Static condition is the load distribution. So braking condition, this is the load distribution. Taking a right turn, yes, then what is the load distribution? You can, from this example, you can understand the variation. From those equations, we can calculate these loads. Okay, thus, from here, all these discussions, we can understand that if you consider this is the top view of the vehicle, and if you consider this is side view of the vehicle, right, side view of the vehicle, yeah, this is x-axis, this is y-axis, okay, this is your z-axis. Right, sir. Now whole issue is when you are accelerating, there will be traction forces like this. Okay, you can see there will be always vertical forces. You are accelerating, also you are taking a turn. Let us say you are taking a turn this way, then there will be grip forces like this. So that means at each point you have a vertical force, you have a lateral force, correct, and you have, right, an accelerating force. Okay, these forces are acting on the contact patch here, say here, effect of these forces decide the behavior of the vehicle. Correct? So study of response of vehicle to the forces that act at the 4 palm size patches is what vehicle dynamics. Right. If you see this one, you can understand this. Okay, right, sir. You can now calculate vertical forces. You can calculate traction forces. I think the idea is very simple. You can calculate load on each wheel. 1, W2, W3. Each load, if you calculate load based on the condition, what is the load coming on this? This, if you multiply by mu, you can find out traction forces. W1, W2, W3, W4 are vertical loads. Let us say mu is the road friction. Based on that, you can calculate what are the traction forces. Same mu L, if you multiply, then you can calculate lateral forces. So in a vehicle, if the net lateral force, let us say, here it is center of gravity. If this lateral force is greater than this lateral force, it will simply yaw the vehicle. Correct? Suppose this side traction force is greater than this side traction force, then what? It can spin the vehicle. Correct? Same way, this force is greater than this, it can pitch the vehicle. So how to manage that equilibrium is what vehicle dynamics is all about. Right? Okay. Now let us look at some forces on a car with a trailer. This is the car, part of it. Okay. As discussed earlier, this is the center of gravity of the vehicle. W is the weight. This height of center of gravity. This B and C are the distances. At D point you have a hitch. It is at a height H2, and the center of gravity of the trailer is at H3 and its weight is WB, and this distance between center of gravity and the axle is F. So assume this vehicle is pulling this trailer. Okay, so let us find out the gradability of such a vehicle. So now I have to just do force analysis on trailer to find hitch forces. Let me, taking moments about the point where the tire contacts the ground counterclockwise moment is considered sigma ty is equal to 0. About this point I will take. Look here now. This is WB sin theta multiplied by H3. This is clockwise moment. FZB is at a distance E plus F is also counterclockwise. This is counterclockwise, this is also counterclockwise. Then WB cos theta into F, this is clockwise. Then what else is there? Here. FXB, this is at a height H2. So that is the thing. So counterclockwise and clockwise moments I'm equating. Okay, fine. You'll get one equation. Forces only along x direction means this force, grade force, this is Fxp. So I'll get this forces along x direction. Similarly, forces and force analysis for car, if I do it, again moments if you take, I don't think I have to repeat again and again. You get these two. Now I have got 4 equations. And I have to find load on front of the car, front wheel, rear wheel, hitch reactions, hitch forces. From those 4 equations, I will get the Fxp value, Fzb value, Wf and Wr. Now let us find out what is the gradability question. So total load to be pulled is car load and trailer load. Sin theta is mu into Wf. It is the traction force. From the previous equation, WB sin theta be there as it is. Mu Wf you take from here, substitute into it. Okay, let us simplify. B plus C is the wheelbase length. LTE plus F is wheelbase of the trailer. WB by W is zeta, non-dimensional weight of the trailer. Put all this and you will get this equation. For a front wheel drive, when I do this, you can very clearly see that again you are getting minus here plus here. That means theta value is small. For rear wheel drive, you'll get plus. Here it is minus. So theta value large. So gradability for a rear wheel drive in a hitch is there. It is much higher than front wheel drive vehicle for the given dimensions. Okay. Now based on all this calculation, based on all this explanation, I have just formulated a simple example, a design example. Using all those equations, I request you to perform the design calculations and get familiar with how to use the equations. With this, let us end up this chapter on vehicle dynamics, that is load transfer.